This is Saxon's Trig, Lesson 9, Congruent Figures and Proof Outlines. All right, so buckle up when we get to proof outlines, because if you got this in geometry class, great. If you struggled with proofs in geometry class, we're going to go over them again, and hopefully they will click for you better this time. And you could have gone through a geometry book that was not Saxon's geometry, but proofs in general just all work the same. But before we get into that, let's talk again about congruent figures. We know that congruent is this symbol with the equal and the squiggle, and congruent means same shape and size. So before we talk more specifically about that, just looking at the bolded words in your lesson, they do a quick review about equal, greater than, or less than, and what those symbols look like. It's not important to this particular lesson. However, numerical expressions and numerals are basically anything that has a number in the problem. And so it is the concept of the number. They're going to get a little bit into the weeds here, but basically just know that a numerical expression and numeral have something to do with the idea of a number. Congruent, we just talked about, and congruent also means geometrically equivalent. To be congruent, same shape and size, the shapes do not have to be drawn the same way. They can be flipped around, turned around, rotated, as long as they are ultimately the same shape and size. So if you look at the bottom of 67, you've got a triangle marked with a 3, 4, and a 5, then a bigger one in the middle, and then another one marked with a 3, 4, and a 5 length of sides. One is labeled A, one is labeled C. A and C are congruent, even though they have been basically mirror imaged, flipped, if you want to say it that way. Also note that when figures are congruent, their scale factor will always be a 1 because they are the same size and shape. So if the size is the same, you're not changing the numbers. So the only way to not change a number is when you multiply it by 1, making a scale factor 1. Okay, on page 68, they return to the term postulate, and they do this because we're getting ready to head into proofs. And the postulate is a statement that everybody accepts without proving it. And then they refer back to when we constructed triangles out of 3 given lines. And you see on page 68 that if I take those 3, depending on, so obviously you're gonna, copy your longest line. If you put the short side here and draw the arc, and the longer side here and draw the arc, you might get the triangle looking like this. However, if you do that same copy and you put the longer one here and the shorter one here, it probably needs to be more like that, you're going to get it looking more like that than anything else. They are going to have the same lengths of however they were, because the 3 lines were the same lengths, but they look very different. Their example's a little different because they didn't use the same bottom base. Mine is more the mirror image thing. For theirs, they did the short side as the base of this one, and then the longer side this way. It's going to look very different, but they still have the same identical numbers. Therefore, they have to be same shape and size. They have to be congruent, even though they look very, very different. Okay, now they move into the next set of bolded things is side, angle, side. So they are talking about proof reasoning when they say side, angle, side. So in a triangle, they will be congruent if in the same order between the two, this side would match this side, this angle would match, this angle would match this angle, scratch that, side, angle, side, side, angle, side, those 2 sides have to line up. So if you have, without jumping around, completely in order, connecting to each other, side, angle, side, you have proved congruency. What other words can prove congruency? You can have angle, side, angle. So that's going to be an angle, a side, and an angle. So we'll say this is a 2 and That was beside the 1. So this would be, so angle, side, angle will work for congruency. I want to make sure I don't miss any that they had. Angle, side, angle, side, angle, side. At the bottom, they give you more of them. Now they say that you can use 4, and you can, angle, side, angle, 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 side. And it's true that you can do any combination of 4 as well, but if you've proven 3, you've automatically proven the 4th. So to avoid extra steps in a proof, we just drop it to 3 parts and you are okay. But you can show 4 if you so desire. Now, side, side, side will work in proofs, but it only proves similarity, not same actual size. I need at least one angle to, I believe that's right, to prove it. Rather than trying to get you the full list right here, I'm going to jump into their next one. I think those are the key ones that you need. Oh, no, that's the other one. Hypotenuse leg. It only applies to right triangles because you have to identify the hypotenuse and then either of the legs will work. And that one only requires 2 parts because the 90 degrees is already implied as the third angle piece, making ultimately the 3, but you only need to have hypotenuse leg. And it would work the same to do leg, leg in that case because that would be the same as side, angle, side. And for hypotenuse leg, that's the same as angle, side, side. Yeah, any other rearrangement of those, that's what I was forgetting. Angle, side, side. I tend to not write that one for obvious reasons. I tend to prefer to write it SSA, but it means the same thing. Okay, now part B is the actual proofs. We've talked about the congruency symbol. When you're doing the proofs, you definitely need to be using your segment, ray, whatever the specific naming is. Also, this symbol means perpendicular, and this symbol means they are parallel. Knowing those things, you should be able to do the proofs that they're asking. So in example 1, they give us a triangle, A, C, B, D, and in the given, which they're always going to, that's going to be your starting place for any proof, given, oh, and these are the steps that I use. I try to mark on my shape what is being given to me so that I have it as a visual to help me in my proof. AD, that's this side segment, is congruent to BD, this one. So I've now marked them. Given AD is congruent to BD. Also, DC is perpendicular to AB, this side. If it's perpendicular, it means this is 90 degrees. Okay, so in a proof, now, are they doing the formal proof? No, they're not doing the formal proof here yet. However, I'm just going to go ahead and do that so that you get used to seeing. Right now, they're kind of writing it out in a paragraph of information, but ultimately they're heading you to this statement on one side, reason on the other. And of course, they would always be numbered, 1 and so on. 1 is always going to be your given things. So you're going to write AD is congruent to BD, segments, both of them. Technically, they don't like you to put multiple things in the same listing. However, I don't find it that critical, so I go ahead and write all of my given in the first statement. So what is my reason behind that? They are my givens. That's easy peasy. Okay, now the other thing I want to mark on my diagram is where am I headed? I want a visual to help me remember what am I trying to prove. Outline a proof that shows AC. So I use a circle to show me what I'm trying to, it's not proven yet, it's where I'm headed, matches with BC. All right, so I know that I need a step 2, obviously, to be next, and I need to show 3 pieces or 2 if it's right triangle, and this one happens to be. So I need 3 statements or 2 statements if it's a right triangle before I can get to my last step, which will be what they wanted me to prove. All right, so based on what I'm given, I have this side already, so that's 1. And then I was told a perpendicular. Now I marked it here, but I didn't write it in my proof. So because these are perpendicular, I am able to say and want to clarify. So you want to work off of what you already have and your diagram to figure out what your steps are. I need to say that angle CDB is right. I should write the word out. I'm just going to say perpendicular, something like that, my symbol for right. And again, it should be in 2 separate lines, but I tend to write them all together. I'm going to do the same for the other triangle because I need to show the same things are happening. So angle CDA is also right. What is my reason behind that? I was told perpendicular, so I can use definition of perpendicular. That's what perpendicular means. Things form right angles. Okay. Technically then, in step 3, they would say, well, a right angle equals a right angle. I might at this point combine these and say something like definition of perpendicular and the angles are congruent because it's there. It's kind of, I mean, if this is 90, this is 90. I don't see a reason to say in step 3, angle CDB is congruent to angle CDA. So I kind of lump it together. All right, so now how many parts do I have? A side and an angle. I'm just going to mark it on this side so I can see it in both. Side, angle. So at this point, I'm probably heading toward either another side or another angle. So can I prove that this side is the same, or can I prove that the next angle is the same? Well, I know nothing about these angles, so no. But this side is shared in both of these pictures. So I can most definitely say CD is congruent to CD. And the reasoning, they're the same thing. That's their identity. And then I have all 3 pieces that I need to prove. So in step 4, I can say that triangle ACD is congruent to triangle, and I want to make sure I put them in the same order, BCD. Why can I say that? Because I proved side, angle, side, side, angle, side. Once I have 2 triangles written as the same, I am ready for my very last step, which is, what did they want me to prove? Another part of those congruent triangles. They wanted me to show that segment AC is the same as segment BC. And here is the fun and final, what you use almost every single time you have proven congruent triangles, requiring the 3 parts or the 2 parts, because of CPCTC. You are going to hear it said so many times during this book, you'll have it memorized. What does CPCTC mean? Corresponding parts of congruent triangles are congruent. Corresponding identical parts from congruent triangles, which is what we just proved, are congruent. They are the same. Corresponding parts of congruent triangles are congruent. CPCTC. And again, you will hear it said so many times. That was example 1. They ask you to do another proof. And again, they're doing it in this paragraph of information, but we're going to try to do in this correct format. I think it will be helpful. All right, so this picture in example 2 shows multiple triangles, E, F, G, H, and D. All right, what was given to me that I can mark? Angle E matches with angle H. Great. I'm not going to put the tick mark. I'm just going to use a single arc mark to show that. EF, that is the same as HG, that. Where am I headed? DF to DG, these two. Okay, so in my statement reason, number 1 is obviously going to be my given information. So you're going to write that out here. Step 2, I need to plan out how many parts was I given in the original. Okay, so for these, not this center triangle at all, just the outer triangles, I have an angle and a side. Now, if I'm going in order, angle, side, angle, that's the side they want me, I'm sorry, angle, side, side, that's the side they want me to prove. So I know I can't use that. I could do side, angle, side. That would be these outer ones. Do I have a way to prove them? Possibly. Could I use another angle? Do I know anything at all about these angles up here? No, not really, other than they've been cut into 3 parts. So I also can't use the 2-parter because I do not have any 90 degrees listed. So back up here for just a split second, I was trying to prove the hypotenuse. I could have used leg, leg, and not done side, angle, side. Once I had said this statement here, I could have said, oh yeah, the 2 that I have are leg and leg, and then I wouldn't need to have gone through my 90 degree one. You could have used that as well. Okay, back to this one. I said I could probably prove that this side and this side are lining up. Are they opposite to equal angles? Yes, they are. Ah, there's what I needed. So DH is congruent to DE, why? Because they are sides opposite equal angles. And that's a rule. If the sides must be the same if they are opposite equal angles. Okay, great. I've just been given 2 of the pieces. I've written the 3rd piece. So I'm ready to say that my 2 triangles do match up. So triangle EDF is congruent to triangle, again, we want to line them up, HDG. Why? Because I had side, angle, side. And then if the 2 triangles are congruent, can I state another piece of them are? Yes. So I can say DF is congruent to DG. Why? C, P, C, T, C. And your proof is done.